Okay, we're going to talk about index laws now. So on the screen you can now see the first of the 7 index laws that I need you to know. I'm going to go through each of these 7 and give a very brief example of each. You might want to pause the video and just write those rules down, or maybe as I'm doing this example you might like to write them down with their appropriate example. But before we go and give some examples, just a quick little bit of terminology. So index laws is to deal with the indice, powers. So if I had something like 2 raised to the power of 4. Now, just to get our terminology right, the entire thing is called a power. Now I know a lot of people call this number up here the power, and if you do, that's going to be fine. I'll know exactly what you mean. But technically, it's called the index, because the entire thing is the power. And this number down the bottom here is called the base. Now if you refer this as the power, like I say, I'm not going to be too concerned about that, but just realise that the whole number, 2 to the power 4, is the power, with the 4 being the index and the 2 being the base. And of course, 2 to the power 4 is something I expect you to be able to work out in your head or on your fingers without use of a calculator. It just means take the number 2, times it together 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16. Now, through the course of this, I will expect you to know your powers of 2, 3 and 4, etc. So I expect you to be able to work out things like 2 to the power of 8 without use of a calculator fairly easily. So again, you just did it on your fingers. 2 to the power of 8 is just 2 times 2 is 4, times 2 is 8, 16, 32, 64, 128, 256. So I will expect you to be able to work things like this out, and I will be expecting you to be able to look at numbers like that and work backwards and realise that it's 2 to the power of some particular index. Alright, let's go through some of the examples of these 7 rules. So, rule number 1 is when you have powers of the same base being times together. For example, 2 to the power 6 multiplied by 2 to the power 3, the answer is going to be, keep the base the same and add the indices, 2 to the power 9. If you're not sure why that works, 2 written down 6 times with multipliers in between. I'm then timesing that by 2 to the power 3, so it's 2 written down 3 times with multipliers in between. So clearly, if I add them all up, the 2 is occurring 9 times. I just add them together. Now, take note here of what the rule says. The powers, this rule only applies if the powers are the same base. If I had like 2 to the power 6 multiplied by 3 to the power 5, I can't do anything with that, because the rule says the base has to be the same. The 2 and the 3 are not the same, I can't do anything with that. Also watch out, another trick on this particular one. The bases have to be the same in the question, and the base ends up being the same in the answer. I've got 2 to the power 6 times 2 to the power 3 gives me 2 to the power 9. It doesn't give me 4 to the power 9. We don't times the bases together. We keep the base exactly the same, and we add the indices together. So just be aware of that. Don't times the bases, don't times the indices. Keep the bases the same, A, and then take the indices and add them together. That's rule 1. Now there should be no surprises for guessing, for the second rule is very similar to it. If I'm multiplying powers of the same base, and I add the indices, if I'm dividing powers of the same base, I'm going to subtract the indices. 2 to the power 7 divided by 2 to the power 4 is going to give me 2 to the power of 3. For exactly the same logic as before. Now, just to set that one out, 2 to the power 7, you write 7 2's down with all multipliers in between, and then 2 to the power 4 on the bottom. So notice here the cancelling going out. A 2 from the top cancels a 2 from the bottom, a 2 from the top cancels a 2 from the bottom, and so on. When I do all that, what have I got left over? 3 2's times together, so that's 2 to the power 3 located on the top line of the fraction. It's rule number 2. Let's have a look at rule number 3. In this particular rule, it says a to the power of 0 is equal to 1. That means any number you can think of, if you raise it to the power of 0 equals 1. For example, get your calculator out and go 2 to the power of 0, you'll get 1. Go negative 7 to the power of 0, you'll get 1. get 18.325 to the power of 0. You will get 1. Now if you want to, in class I can give you some demonstrations as to why that works, but I was going to save a bit of time on this video and I'll show you in class if you're interested. If you take any base and raise it to the power of 0, you'll get the answer of 1. The only condition is the base itself cannot be equal to 0. If you got your calculator out and went 0 to the power of 0, you'll get an answer that is not defined. That's rule number 3. Let's have a look at rule number 4. We call this one the power to a power law. Inside the bracket is a power, and then the entire thing itself has been raised to another power. For example, if I had 3 to the power 4, all being squared, in this particular situation, we times the indices together. This is the only time you multiply the indices together. M times n. So it's going to be 3 to the power of 8. Why does that work? Because when you're squaring something, you're timing it by itself. So what is that something? Well, it's 3 to the power 4 being squared. So according to rule 1, 4 plus 4 is 8. 8 is the answer. So in this particular format, you times them together to get the 8, or if you expanded it to that format, you'd add the 4's together to get 8. So that's rule number 4. In rule number 5, it's like the distributive law of indices. When you have two numbers located together inside a bracket, and that bracket is raised to a power, everything inside the bracket receives that power. So the rule would be the A receives the power of M, and the B receives the power of M. Let me give you some examples of how this works and doesn't work, because this is one that can cause a few troubles if you're not paying attention to what you're writing down. In this particular situation, inside the bracket I have 2x to the power 3, all raised to the power 4. So everything in the bracket gets the power. So the 2 receives the power of 4. The x cubed also receives the power of 4. Of course, 2 to the power 4, by now I hope you would be able to work out quickly that is 16. Now, by our rule number 4 over here, x to the power 3 to the power 4 will be x to the power of 12. Now, if you have this situation, 2 lots of x to the power 3 to the power 4, once again, the power of 4 is applied only to everything inside the bracket. The 2 is not the 2 is not inside the bracket. So only the x to the power 3 to the power 4 applies to give me x to the power of 12. So please be aware, what is inside the bracket gets it, what is outside the bracket doesn't get the power. Rule number 6 is just exactly the same as rule number 5, but instead of the two numbers inside the bracket being multiplied, the two numbers inside the bracket are divided. So just like both the A and the B receive the power of M, once again here the A and the B receive the power of M. So there's no real need for an example there. And then last rule, number 7 coming up. Number 7, the negative index law. So if you ever have a power with a negative index, you can move that negative index to the bottom line, make it a positive index. So what do I mean by that? So let's say I look at 2 to the power of negative 3. It has a negative index. I want you to be able to see at the moment, that's actually a fraction. Every number can be written as a fraction. If you can't see it's a fraction, you can just write it over 1, it's now a fraction. But every number can be thought of as a fraction. So when you have a negative index, you can move that power from one line of the fraction to the other and make the index change from positive to negative or negative to positive. So according to the rule, that 2 to the negative 3 on the top line can move to become 2 to the positive 3 on the bottom line. Now, where's this 1? Well, it's still located right down there. So we don't really need to put it in because times by 1 doesn't change its value. It's on the top line. What remains on the top line? Well, technically that's 1 times 2 to the power of negative 3, so it's there like that. So what does it look like? Just if you had 2 to the negative 3, all I would expect you to be able to do was 1 over 2 to the positive 3. What are some other applications of this? Let's have a look at this one. 4x to the negative 2. Once again, it is a fraction because it's all over 1. The negative index, that power can be moved to the other line of the fraction to change it. So at the moment, the x that is the negative 2 is attached only to the x. It's not attached to the 4. So the 4 is going to stay exactly where it is. Only the x to the negative 2 goes to the bottom and become x to the positive 2. Which then, if you had this question set up this way, you have this situation. Now the negative 2 is attached to everything in the bracket. So that would be a case of like that. Of course, you then expand that as you normally would. 1 over 16x squared. Things can move off the bottom line. So if I had 3 over 2 lots of x to the negative 4, the negative 4 is attached only to the x, not to the 3, not to the 2. So they stay exactly as is. X negative 4 comes to the top to become x positive 4. Now, you don't even have to change it from negative to positive. You can change it from positive to negative if you want. If I had 1 over 3x to the power 5, if I wanted to, if it's going to make my question any easier, I can leave the 1 and the 3 where they are, and the x to the 5 can go to the top line to become x to the minus 5. Whenever you move a power from one line to the other line, you change it from positive to negative or negative to positive. And that's what this rule means. You switch it from negative, move it to the bottom, becomes positive, or vice versa. And there's the first of our 7 rules to do with indices. 2 more to come on the next video.